Hi there, Robert here from the Department of Engineering at La Trobe University. Today I'll be talking about educational escape rooms for inescapable learning. Now, I think we all have a problem in the classroom with not everyone being engaged in the classroom, and there's lots of reasons behind it. Some of them we have control over, like what we're teaching and how we're teaching and the sort of methods we're using for teaching, but there's lots of things we don't have control over as well. Things like what frame of mind people are in, what distractions there are, or what's out the window, their boyfriends, girlfriends, their home life, all sorts of things like that. Well, that brings us to escape rooms. What actually are they? Well, it's a global phenomenon, a global game that started in 2007, originating out of Japan. And it's become a very popular game, and the general idea is you take a bunch of people, lock them together in a room, not normally locked, but they're confined to a room. They need to solve a series of puzzles to escape from that room. Often they're sequential, one leads to another, and they unlock a whole bunch of clues. And it's under time pressure, typically 60 minutes. So they're great for teamwork, great for problem solving, and they're good fun activities. And lots of companies take their employees out to these sort of events, and they run an event together. And it's a team bonding event as well. That brings us to educational escape rooms. Now, most of us don't have lots of little rooms that we can lock students up in, and all the puzzles to actually cater for all those little rooms. Well, the way we do it is we use what's called tabletop escape rooms. So puzzles are in sealed envelopes. Typically, we've got 3 envelopes, which gives us 3 rounds of puzzles. And we aim for groups sitting around the table of between 3 and 5 students. The idea is the puzzles should each have a numerical answer and only one solution per one. Now, we basically need some way to verify the students' answers or tell them they got the correct answer. And the way we do it, rather than using physical padlocks, we use this thing here, the Escape Room Decoder Box. This is something we designed in-house, the world's first reconfigurable electronic escape room decoder box. And basically, you can configure it with any code between 1 and 8 digits in length. You can assign penalties for it. So if students guess the wrong guess, you can assign a 1 minute or a 2 minute or no penalty for that matter. It automates clue delivery, so if people have been stuck for 5 minutes, every 5 minutes it gives them an extra clue, gives them an extra digit of the final code. It has a countdown timer on there that's settable between 1 minute and 99 minutes and allows participants to track their progress and how much time they've got remaining. Data analytics, so you can work out how many minutes they took for each puzzle or how many wrong guesses the participants have taken for each puzzle. One thing that we do within these escape rooms is we have a theme. So we want them to be fun and immersive, and we create a storyline around these. Now, there's lots of different storylines. We've had everything from earthquake cave-ins. We've had mad professors' labs that students need to escape from before they self-destruct, all sorts of things like that. We typically make them progressive, and they can reveal clues along the time and make them a bit of fun. Now, these are currently written in text, but you could do 360 videos or augmented reality or virtual reality. All of those sort of things could be incorporated into these themes as well. You can use QR codes and things to enhance them a bit too. Well, that brings us to the puzzles, and within engineering we've had heaps of different puzzles. We've used these from everything from engineering to maths to biochemistry to theology to physics, a whole range of different topics. But we'll concentrate on the engineering ones for the moment. So you see up the top there, we've got different number bases that we're adding together. Decimal, hexadecimal, binary, they add together. So there's all sorts of conversions that students need to go through there. Just here, we've got a serial string that we've actually sent out, and the students need to decode that and work out what the ASCII character related to that one is. And sequential ones spell out a number like TWO for 2. We've had electronics ones here where students need to put pins on various things and use a multimeter to work out what's connected to each other, what voltages are coming out. We've had digital lookup tables and things. But these sort of things can be in many different forms. You can have, you could do gears with these. We've done ratios of weights on balance beams and things, so more physics related ones. Here's a few other ones, and some of these are showing that it's not necessarily just engineering related. The one just above there is a safety one, and so looking for hazards and working out what segment the hazards are actually occurring in. We often use little ciphers like this pigpen cipher here. That was used during the American Civil War, and that pigpen cipher students need to decode clues with. And we've got one that we use for students, particularly new students coming to Australia and studying with us, which is an Australian escape room over the far left side. And that has a whole lot of puzzles around Australian geography, Australian slang. We have our own kind of little language at times, and Australian inventions that have been invented over the last 100 or so years. Well, one of the things we get asked a lot with these is if we don't have numbers, can we still use them? Because our keypad is a numeric keypad. And what we like to say is there's lots of ways to make something that's not a number into a number. Some of them are using things like Roman numerals or spelling out numbers. Quite often we use some sort of a lookup table. So there's a lookup table of binary digital logic elements there, but you could also have lookup tables of years or lookup tables on the periodic table or all sorts of things like that. You can have things like A equals 1, B equals 2, and so on, and look up tables with shapes and patterns and sounds and all of those sort of things. There's lots of different scope there to integrate escape rooms in these sort of areas. In terms of evaluation, we've ran these with over 1,000 participants. They've been very, very well received. Participants have described them as a fun activity. They've also described them as an activity that uncovered areas of knowledge that they didn't realize they had, but also uncovered areas of knowledge that they are deficient in. Sometimes they make a mistake when they're studying for exams. They kind of look at the question, then turn to the back of the book and look at the answer and think, oh yeah, I knew how to do that. But they didn't. They tricked themselves into thinking they knew how to do it. Well, they don't get that option here. They need to escape with their team. We're seeing students entering into flow here, where they're starting to lose track of time, lose track of surroundings, and do some really great teamwork and peer learning as they help each other solve these escape rooms. We published a bunch of papers on these, including ones in IEEE Access and Transactions in Games, but this is an area ripe for publication. All the publications in this area are from 2017 onwards, so it's a very recent area and a very exciting area of research to engage students in.